the idea behind the black hole is, let's say you take the sun, a star the mass of the sun, and you just collapse it, and you keep on collapsing it. You get to a point when the radius of the sun is not 700,000 kilometers, which is what it is in miles, 500,000 miles. I'm going to use kilometers because I can't remember the things in miles.
Our audience will appreciate that.
Everyone can convert it afterwards, right? So 700,000 kilometers. And you squash it down, and you squash it and squash it until its radius becomes 3 kilometers. 3. Then there are several ways to look at this. One is that on the surface, the speed you'd have to travel to escape its gravitational pull, it's called the escape velocity, would exceed the speed of light. That's one way to think about it. So even light rays emitted from the surface, if you could squash it down that far, would just stay there. They would not escape because they'd be trying to go at the speed of light, and the escape velocity is the speed of light, and they just stop. So what happens then if a star collapses inside that number, which for the mass of the sun, 3 kilometers, is called the Schwarzschild radius, then it will collapse without limit. Nothing will stop it. And so all you will get is essentially the geometry of space and time, the curvature. And that's a black